for a minute. Okay, so we recorded it, and maybe for recording, for sake of recording, Jinglian, would you please share the slides on the title, and then we'll move on. Okay, so please. Compositional generalization. Okay.
Yeah.
So maybe you can briefly explain what is compositional generation and how it is different from general generalization.
Sure. So we go to the introduction part. So the problem is that NMT benchmark models have high blue score in many data sets. For example, this is a sample data set, but the performance is low in out of domain and low resource conditions. And the case they want to discuss is that even benchmark model is not robust enough to input perturbation. So this is their first example of some web translator.
So the performance is about the generation, right?
Yeah.
The translation. So can you more specify what is out of domain problems and why the performance is low in the low resource condition?
They just mentioned here, this is not the main focus of this paper, but I think out of domain is like, for example, your training data is within some distribution, then for data in another domain is kind of doesn't really follow the similar distribution as your training data. So the test result will be very poor.
And maybe you can go through a little bit about the examples.
Yeah, the example here, they say that they have a popular web translation engine, and even you just like change one letter here, the translation will be totally different. And this is a
so this is an example in the real world case. So the meaning breaks will actually be converted into keeps, right? Which is totally the opposite.
Yeah.
So this is more about the model vulnerability. Okay.
But I think this example is not really very good, and it's like not really aligned with their main claim. So they're saying that the main cause of sparsity is semantic composition. So even you have a limited vocabulary, the possible combination grows exponentially, and that will cause poor performance. Yeah, when you compose all vocabulary together. I will have more examples.
Yeah, I don't quite get why here the sparsity really matters. So which means that some of the compositions does not appear frequently in the training data set.
Yeah.
So the idea is that they want to have a better performance for some other composition, right? Or the combination.
Yes, then that's the idea of compositional generalization in the title. So if red cars and blue balls are both in the training, then the competence algorithm is expect to translate the red balls correctly, even it's not seen in the training data. So this is the adjective and this is a noun. And when you randomly combine, you should translate them correctly. And that's the idea. So the challenges increase as a composite length grows. And from the original paper, they said the capacity to systematically generalize to novel combinations of all the compounds are learned sufficiently during training. Yeah, that's idea.
But if there is a word-to-word translation, why it is a challenging task, right? Suppose we have a rule, the red correspond to hong in Chinese and the cars corresponding to 车 in Chinese. So the sequential combinations were just translate the red balls correctly. And I didn't see it is a challenge.
They will have more examples later.
Okay. Yeah, I understand. So here on is Yufan there?
Yes.
Okay, so maybe this will be useful for us because if we want to translate the code to comments or vice versa, or the opposite, translate the comments back to code. And we also have very important compositional generalization problem. And but the case is that how do we do the appropriate segmentation? Maybe we can borrow this technique in our work as well. Okay, so that's for my comments, and Jinglian can move on.
Yeah, so they feel the current approach, they have no enough sample, and the current papers only makes simple modification in sample sentence. For example, adding, removing verbs, concatenate two sentences. So that's not enough. And they want to
I'm sorry, why this existing approach can address this compositional generalization problem?
no, this is not their approach. They mean the historical approach.
Yeah, I know this is historical. So usually we will have the pattern, right? So it's throughout the questions, and then it will compare and illustrate why existing approach cannot address this problem. But this approach kind of relevant. And the question is why this approach relevant to address this compositional generalization?
Anyway, you want to combine and the existing solution, for example, just like do possible combination like verbs or combining, but that's not qualitative enough.
I still don't get why concatenating two sentences can address a compositional generalization.
Yeah, I don't think that address it as well, but they just mentioned it here.
All right, so maybe we can move on. Yeah.
Then we goes to some basic terms. They use two concepts. The first one is called atoms. So they are primitive elements in the training set, and they are basic semantic components. And there is concept of compounds, and they are obtained by composing the atoms. So in this paper, they address the problem of NMT, but actually this idea can also be used to other data sets. For example, in this data set, their compound is kind of like an instruction, and their output is kind of a converted version of that. And for this is question, this is also like a code generation problem. And in this case, their atoms are a question pattern, and then what can you fill in the pattern? And the compounds is a combined solution, and then your target is what you
so maybe I still have questions here. I know that this paper written by Prof. Zhang Yue, or maybe his students, because I find that his ranking, his paper is almost the last one. So this may be the walls and tables organized by his students. So the question here, so when we're talking about the idea of atoms and the compoundants, right? So the compoundants consists of atoms, right? More like the molecules consist of atoms, and the word actually constitutes a sentence. And as for CFQ the instance, the atoms is basically an abstraction, and the example of compoundants is basically an instance of that abstraction.
Yeah.
Right. So is that appropriate examples, or this analogy or these metaphors can be extended CFG or CFQ?
From what they claim in paper, they think this is a appropriate pattern for CFQ.
This is basically a template and the compoundants. So it is very hard for me to agree with that. The template will be atoms and the instance will be compoundants, and it is seems not logically correct. So I just raise a question here. Anyone had questions or have the idea here? Yuchen, what do you think? Yuchen there?
Hi, yes.
I'm asking about, I'm just raising a question about the concepts, the logic relations between atoms and compoundants and the templates and instance. I think they're different relations, but just in the paper that, yeah. Okay, maybe, do you have an idea on this instance?
Not really. I feel like I don't have enough background knowledge.
And how about cushion?
Well, I'm just following the presentation. Have not formed enough.
Okay. Okay. So maybe we can maybe we still move on.
So maybe we can read the paper for this example. But anyway, in this case, they focus on this is their database they proposed, and the atoms, for example, have nouns, postposition, and then the sentence is a combination of all atoms.
Okay, so in this case, how do they identify the atoms, components, and a sentence? And here they do not have the definition of sentence, right? Or the sentence is very straightforward. They will still propose the concepts of atoms and compounds. And what is the way to slice or segment the corresponding range for atoms and compounds? They mention this.
Later, they will know the sentence are the data set they find, and the data set is all the 5 sentence stories. And then by slicing them, they just use the existing segmentation tool. Yeah.
You can see, so we can have existing segmentation tools, but these segmentations just pass the syntax of the sentence, right?
Yeah.
And they will not directly tell you what is atoms and what is compounds.
Yeah. Later you will know for the tool will label each word what they are. Are they noun? Are they adjective? Are they preposition? And then they combine based on their pattern.
So the pattern is predefined.
Yeah, they define it.
Okay, let's move on.
Yeah, so they also have the idea of normal compound. So this is an example. In the original text, anyway, what I highlighted here, and for the translation part, this highlighted part is translated wrongly, and they think the novel compound is appearance rate. So here is appearance rate, but in the translated sentence is look. So they think this novel compound is composed of 2 items, and both 2 words have high frequency, but this sentence semantic is completely distorted. So that's the issue. They have high blue score, but fatal error here.
I'm sorry. So the blue score is a translated result, right?
The blue score of other words are very high.
I see. Yeah. So, but by the way, so apart from blue score, to your best knowledge, is there any measurements for the translation evaluation?
Definitely. We used raw trial score, we used media score, but for this fatal error, I guess not really.
So basically, we're talking about semantics. So we're using the other models, just more like when Chen Yan is there. So we're saying that sometimes when we try to evaluate the performance of models, we were using the other model, a more reliable model to evaluate the existing trend model. For example, if we want to evaluate GAN, right? So we still need to using some existing model trained by the internet to evaluate its diversity, to evaluate its quality. And maybe, I don't know, I think there must be a way to evaluate the translation results, the translated results in terms of semantics, right? So here the appearance rate means that means attendance instead of looking. So somehow there must be a way to do that.
So you try different models if.
Yeah, so think about it. So for example, given a sentence, I'm saying that so today is a good day. I like the weather very much. Or today is a good day, but I hate the date very much. So there are totally different semantics, showing different emotions. But the blue score is very, very high, right? So if we want to have a bit, especially when we working on a translation problems and what is the best way, the best measurement to extract the semantics difference. And also sometimes I think that this is a good day and this is a good day. I like the weather very much. I would say that I can say this is a time I like it very much, and the weather is very enjoyable. And these two sentences are basically of the same semantics meaning, but of very different blue score, right? So I'm not sure whether it is possible, but in the future, if we still work on the comments generation, translation, code generations, maybe a better measurement is required other than the blue score.
Okay.
Okay.
Before going to their setup, this is a summary of their data set. So as we said, they have compounds and atoms, and they, I think their main deliverable is this three part. So they have standard training, validation, and test set for the translation error. And they have a compositional generalization test set. So within this set, they have novel components in each sentence. And they can get the generalization error rate from there by computing, by using this data set. So they are.
And how, so this is a manually constructed data set, right? So which seems that it's more like a variance or mutation from an existing data set.
Yes.
So how do they do the mutation? The red bar, the blue car, and do something like this?
In next few slides.
Okay.
And the third deliverable is that they have a Python script, basically. They can automatically get the translation error rate. So I went to their GitHub page and it's very straightforward. So the first part under the data, they have the standard three set. So this is source, this is a reference. And under their data CG test, that's what they said, the novel composition. And they have norm, what's this? A verb and preposition. So for here, you have the compound, and then you see the compound in the source, and you have a compound in the reference. And they have an evaluation script. And for the evaluation script, your input is a source split by the compound and your translation. And they also have a reference lexicons for all the compounds. So you compute the error rate of the translation.
So anyone have a question for this data set?
So no atoms here, only compounds.
Yeah, each of them are atom.
Yeah, I just feel what's the difference between the atoms and words?
They are same, but items have different types. Later you construct them and combine them.
Okay.
So here, so I would like to confirm that atoms is something invariant, right? So whatever it is, whatever the change, the atoms will not be broken. So just like a single word, the weight, right, will not be broken. But the point is that given their definition, an atom can consist of a sequence of words, right?
Mm-hmm.
So just like Dr. Xiaoyan mentioned, here it just lists the compounds, but the point is the compounds is changeable, right? So why do they label or annotate the compounds instead of the atoms? So I think in a very straightforward way, I think it's more convenient for us to annotate the atoms.
Maybe I can go to that part first. So you can see each atom is something like the det or the norm, but your composition is a combination of all items, and it can be really complicated based on all their patterns.
So here, so which one is atom?
The norm or the det determined.
What determine?
Determine.
Determiner means that, right?
Yeah.
Determiners, nonce. So this is a patterns for deciding an atom or a compound.
Yes.
No. What I'm asking, atom. This is a pattern for defining atom. This is a pattern for defining atoms or compounds.
Compounds.
Compounds. But how to define atom?
Item are just like norm verb. They use the Berkeley parser to directly get all the items.
So here, if atom consists only one word, it is very trivial, right? So each word, it is determiners, it is the verb preposition. It's very straightforward. It is very trivial. But my point is that how do we glue a sequence of words into an atom? How do they decide it?
For example, here the mode post-positive modifier is he liked. So this item mode consists of 2 words, but I think the result is directly from this pass.
Okay, from Berkeley. So we will have still, I remember there is still a Stanford parser. Okay, so that's the, okay, we can move on.
Okay.
And here, sorry, I still would like to confirm this. So this is a data set for evaluation, right? For evaluation, so the compounds is the waiter, and another lazy lawyer. And how do they derive this compositional data set?
We go to
so here we were talking about evaluation, right? So for certain problems, and we would construct the training data specific for this training problem. And how do they do this? So which means that we have some training data and learn it, and the test data would represent certain features of certain requirements of the generalization capability or the compositional generalization capability, right?
Yes.
And how they do this?
They have I think their training and validation are here, and they have test data. And
yeah. Now that they have test data, I'm asking how do they synthesize the testing data?
Synthesize.
Yeah, right. So they need to synthesize this data, or how they pick the test data. So this is a data set specifically designed for evaluation of the compositional generalization.
Yes.
Right. So how do they do this?
I don't think they mention. They just like give some number, like 10% of the data.
So here is that I think so. We're saying that if we want to evaluate the generalization, especially the compositional generalization, it cannot be an arbitrary test case. It cannot be an arbitrary test sample.
Yes.
Right. So it must be somehow relevant to the training data, but it will be slightly or different from the training data in a way, so that they can evaluate whether the model has this kind of compositional generalization. So there must be a way to construct the training data, the testing data in a specific way.
Yes. Then maybe we go to the data set construction process.
All right, maybe I broke your logic chain. So if you think if you're naturally comfortable with your own logic chain, can still keep going on. Maybe I raised the question too early. Whatever comfortable you.
Yeah, we will discuss it later.
Okay.
So first of all, this is how they choose the data set. As we mentioned, they want to minimize the influence of some additional factors like stylist problem. So they use the simple data set. They didn't use this too, they mentioned it, but they use 5-sentence stories. So they are quite simple. And they only select the top 2,000 frequent words as the vocabulary. And then they extract sentences where the words are exclusively from the restricted vocab. And they also remove a sentence that's too long. So they clean it. And then they call this parallel data construction. Basically, it means they use a public translation engine to obtain the model generated translation, and they ask people to further modify them and refine them. Yeah, they use a human expert for the Chinese translation.
May I ask, it is the construction of training data or testing data?
I think
Yeah.
both, right? So here it's,
Both.
I think it's for both, but I haven't see how do they derive that special data for their special task.
Okay, yeah, maybe let's wait.
Yeah, yeah. So they use the parser to get the atoms, like all of them here, and then they design these patterns. They have 12 patterns in total, and this is a pattern, all right. And then they use this center to get the post tagging for each word, and then they combine them. They
Oh,
first.
sorry. So what is post tagging?
I think it's just like this.
Okay, so more like annotate the nature of each or property of each word.
Yeah, so they select the atom candidate with a relatively consistent translation in the training set. So their frequency of candidate atoms is like in this range, and the list of them, and they enumerate them to.
I didn't get it. So what is the range from 34 to 73K? What does it mean?
I think it's a number they appear in the training data.
I see. Okay.
Yeah, and they enumerate and combine, and they manually remove bad ones.
And the question is, what is average length of the atom?
Where is it?
Do you know? You're there. They were specified it.
In the appendix.
Okay, so it must be not one, right? Suppose some length over 2, 3, etc.
They didn't mention the appendix, but we can look at the data set ourselves if we need. Yeah, and actually, so that's a manual work. They go through them, and finally they obtain 2K compounds, finally, following the previous pattern.
Oh, sorry. So this is the patterns, atom, the pattern. So compounds. So when they by this means they identify 2K compounds.
Mm.
And then they were mutate and change these compounds. So you can see, so they at the fourth bullet, they were saying that they do not deliberately make all the compounds unseen. So there must be a way to eradicate or remove those compounds, right? Or change those compounds as much as possible.
Yeah, you got a type and you got candidates, then you just enumerate all combination and fill in and see the result for the compound.
Okay, you can keep going. You can move on. Any questions here? I think it's quite clear now. So up until now, Jinglian is all talking about how to construct such a data set, which will be specific for the task. If there are no questions, we can move on.
Yeah, so they are saying that even all the items are very commonly seen, but for the combined compounds, only 0.93% of them appear as a combination in the training data.
Okay, so yeah, so any questions here? If there are no questions, we'll move on.
And then after you grab the compound, you are trying to create the sentence. So you embed the compounds in specific context to form the complete source sentence. So again, they use a Berkeley parser to get the sentence template. For example, you have a placeholder for noun, and then you fill in the compound into this placeholder to get a sentence.
Filling the compound. Suppose I think it should be filling the atom, right?
No, the compounds have 3 types. They have norm compound, verse compound, and prepositional compounds. So
and one compound consists of several atoms.
Yes.
Right. So my point is that we we will not preserve the compounds. As you mentioned that the compounds will be, there is almost no compounds shared between the training and the testing data set, right?
Yes.
And here, so the question comes to what do we preserve from these compounds? So basically they using the Berkeley parser. So as far as now, before that I only know the Stanford parser, but whatever. So when for the Berkeley parsers identify the compounds, so you're saying that then we're now at the stage of changing the compounds with the atoms, am I or not?
Yes, that's
Okay.
right. That's right. So you fill in the new compounds into this sentence.
Fill in new compounds or new atoms. So the compounds is just compounds. So my question is whether it is atoms. So we can see that suppose the compound consists of several atoms, right? The NP placeholder spend a lot of time to set up weddings. So suppose this is a compound, it must be able to be divided into, we're able to divide it into several atoms. So we just need to change the atoms. And the pattern will still be preserved. But the old compounds will be gone. We will have a new compounds.
Yeah, and yes, you fill in a new compound here. For example, here you fill in a new norm compound. For example, these four are all norm compound, and you see if you fill in these four highlighted parts into that sentence, the sentence still makes sense, right? So another lazy lawyer spent a lot of time to set up a wedding. That's also makes sense.
In that case, so you're talking about the test data set generation, right? So if we replace the NP placeholder with a compound in the training data set, which means that this compound will be shared between the training and testing data set.
They don't put it in the training data set. You can see here the original data, the real world data are split into these three, but for this constructed data, they put in this CG test. They are separate.
What is CG test?
The CG test just like here is a special data set under this part. They don't use this for training. They just use it for test the generalization model after you finished your training.
Yeah, so they just used for testing, right? So this is just for testing.
Yeah.
So I still get confused because there's something contradictory on giving the talk. So here, the first I would like to raise the fact and you answer yes or no. So here, giving the test, CG test and the training data, and these two data sets share very small amount or hardly share any compound.
Yes.
I mean, yes, right. Is yes, right?
Yes.
So the second question is that this CG test is derived or generated from the training data set, yes or no?
Yes.
Okay, so there must be a way to transfer the training data into the CG test data so that they will share very little compound, yes or no?
Yes.
Okay, so in this case, why we would like to replace the compounds, replace that NP placeholder with compounds. If we replace this with the training set compounds, it will still make the training and testing data share the same compounds.
But they mentioned the amount is very small.
Yes, the amount is very small, which means that the construction process in the construction process, the author would like to try their best to minimize the shared compounds between the training and testing data.
Yeah.
So let's back to the previous questions. So when we are using the Berkeley parser to find the compounds, right? So why we need to replace the whole compounds with another compound, right? So here the example is NP placeholder, spend a lot of time to set up a wedding, and which parts is a compound? NP placeholder.
After you replace, it's a compound.
Okay, okay. So, but this compound does this compound appear in the training data set?
It depends. I don't think so.
I'm
not sure.
And how likely it will appear in the training data set? or
Mm.
are all the do all the compounds come from the training data set, or is there some other sources?
Compounds items are from training data sets, but after you combine, then like these amounts appear in the training data set.
So let's come back to the next slides. So you're saying that this NP placeholder, we replace this placeholder with a compound in the training data set, so that we can construct a new sentence in the testing data set.
Yes.
Uh,
This is a template, and for every compound, they choose 5 templates. And for example, here the red dog is a compound. Then you choose 5 templates like this, and then you create 5 new test sentences.
So, okay, so there's 3 levels data: atoms, compounds, and the sentence. So they will try to replace the compounds, anyway, a word or a component in a sentence with the compounds in the training data set. So this is what they're doing now. In that case, why bother to look into the atom? So, or maybe that is just a tool or utility to construct compounds.
Yeah.
But it still confused me that if that is way to construct the testing data set, why there are so little shared compounds in these 2 data sets?
I guess maybe because of the combinations,
No, so you can think about the world is like this red dog, right?
Yeah.
So if this so there's hundreds or thousands of the compounds will be used to replace the sentence, right? So if it is the case, there's supposed to be the huge number of the compounds shared between the training and testing data. So which is contradictory fact to that there's only 1%, less than 1% of them sharing, less than 1% of the compounds shared between 2 data sets.
Oh, maybe because it grows exponentially. So after
And how this grows exponentially. So we're talking about the compound. So we're talking about the compounds, right? And we replace some word in a sentence with a specific compound in the training data set. So if that is case, compounds there must be a very large number of compounds or high ratio shared between the training data.
Not from their statistics.
Yeah, I think there's some confusion there. So anyone will have the question here, or will try to explain it. Yufan, have you read the paper before?
No, I think that's a data augmentation.
Of course, it is data augmentation, but it is augmentation, which augmentation is a way to enlarge the training data set, but this is a way to construct another data set, which is to check the compositional generalization, right? So anyway, I think we will not spend too much time here, but the overall idea, the abstract idea is that there must be a way to compose a new sentence which leverage the knowledges of the old sentence. We're going to check whether the new composed sentence will be well performed. After all the atoms have been seen in the training data set. We want to see whether they can compose well in the testing data. So this is abstraction, right?
Yes.
Okay. And also for the label of the testing data, I mean the CG test, so they're also hire the students to manually label them, right?
Yeah, not really label. They hire people to post edit the translation.
All right. So anyway, that's a way of label, but in a cheaper way, instead of ask the student to write everything down. Okay.
Yeah. So finally, they mentioned they collect so many data. Original data set is this much, and they split, and they have the additional CG test data set. And lastly, they said they have an automatic evaluation. That's basically a Python script. So your model output will be the test sentence, the compound, and the model translation. Then the tool basically just only check the compound and see if the compound is labeled correctly. And they mentioned that their automatic tool achieves precision of this much compared with human annotation.
So evaluation tool.
Yeah, a Python script.
Sorry. So this is supposed to be 100% accurate, or also okay. The human annotation is ground truth,
Yes.
and this automatic evaluation tool anyway up until now we haven't discussed anything about approach, right?
Yes.
So this is a heuristics or rule-based approach to achieve this precision recall.
Yes.
So I didn't get it. So suppose here, the ground truth here. So this year, one sentence, the lawyer ended with winning the second prize, second place.
Yeah.
And the compound is the lawyer,
Yeah.
and the translation is Chinese 律师, whatever.
Yeah.
So the prediction is that, so given a sentence, we identify the lawyers and to see whether the Chinese translation lawyer appears in the results. Is that the case? So what is the evaluation task?
Evaluation is just they say if the compound is matches the lexicons here.
So they're checking. So here there must be a model, right? There must be a model which is able to translate the lawyer into a Chinese version.
Yes. So
point is that we have the talking about the approach. So how this automatic evaluation? What does this automatic evaluation mean?
From my idea, they are just saying that human evaluation. They just get a replacement for human evaluation.
Get the replacement of the human evaluation.
I feel like they just want to say they have a automatic tool for evaluating the compound.
But this automatic evaluation, so how this automatic, so is this automatic evaluation tool is their approach?
They didn't mention that approach.
So is this baseline? Yeah, so here there's something weird. So usually when we given the presentations, we you somehow be responsible to explain what you put on the slides, right?
Yeah.
So I know that sometimes some students were maybe you find, I'm not sure who is this. So we remove some contents, but the logic is coherent. So that is also good. But here there's something stuck there. So or maybe my next question is that understanding this automatic evaluation tool is very important for understanding the whole work.
They address it as a main contribution of this paper as well.
Okay, so this is a main contribution, right?
I think, yeah.
All right, let's move on. So yeah, so better. So anyway, so after when you master graduate, I'm not sure how you were going to develop, but how to organize the sentence or the contents in a logical way, articulate your ideas. So that is also very important. Okay, let's move on.
Okay. So they do their experiment. They use a transformer model and they use the existing tokenizer, and they train in this way with this parameter, and they choose the best checkpoints on validation set for evaluation. And they do evaluate in two ways. The first is a character level blue score. And yeah, they didn't, you see here in their evaluation, they use the expert. So they use human power. They didn't use their previous automatic script for this result. So we can go to the data part. So
Okay, so you're talking about so it is experiment, but we haven't discussed any approach until now.
mm,
So you just so the idea is that you want to finish all the experiment, they show their performance, then you discuss how they design approach. So this is your logic.
they don't they what approaches are you expecting? They didn't really mention in this paper.
Okay, so this approach is not a technical paper.
Yeah.
So they're just saying that this is a very important problem for us to address. They
Three
don't.
part. The first part is how they do the data set. The
Okay.
second part is their experiment. Then the third part, they analyze maybe some potential syntactic reasons why NMT models are not good. Yeah.
Okay, so this is more like empirical study.
Yeah.
I see. Okay, so and also here, so here it is really important. Now I come back. I need to come back here for that automatic evaluation tool.
Mm.
And how do they construct these?
I didn't read, they didn't mention in the paper, and I didn't read their Python script.
So anyway, they will have a tool which is able, so the task, so maybe I try to guess it and you will correct me if I'm wrong. So here, so we can see that in the data set, so there's one sentence and there's one compound from the sentence and there's the translation, right? So this is labeled data, this is labeled data. And for this data, there must be part of prediction. There must be part of input and one part of prediction. And which part or which component is the input and which component is the prediction?
This is not a model. So for this script, your input is this one, the model's output. And I guess they look at this compound and then they check the Chinese letters for this compound and they see if this letter appear in the model translation. Then if that's a yes, they will say this compound is predicted correctly. I guess that, yeah.
So do they need to predict corresponding compounds or they're using some parser to identify the compounds?
You see your input is split by the space. Yeah, so you just get it.
I see. So that is defined compounds.
Yeah.
Right. So their evaluation tool. So this tool contains a deep learning model.
No.
It's not a deep learning model. So they were just okay. So point is, I see. So the idea is that so giving this one, and they were so this lawyer may have multiple meanings based on the context, if I'm right. So they will have a referenced translation, so whether to Fuyuan, etc., etc. So maybe there's another word bank, and it will attach only one Chinese translation, maybe 银行, but there's also another translation, but it is not listed in it. So they will have the baseline might I just say might. So choosing the words with the maximum frequency. So whether maybe there's other meanings, but Fuyuan is a common sense. And the bank has many meanings, and maybe 银行 is the most used one. So they're using this reference text to achieve 95 precision and 87 recall. So am I right?
Yes.
Okay. All right, we can move on.
Yeah, then this is their result. So you have the original test trained data set and you have the CG test. And under the CG test, you have three subtypes. They are noun, verbs, and preposition. So they are saying that the CG test that the performance of the transformer drop dramatically. So they are saying that the unseen compounds pose a very significant challenge.
And see, this is unseen compounds, but you are saying that you are replacing existing compounds to the CG test. So there's a sound gap missing. But anyway, they will consider something they didn't see.
Okay.
Right.
Yeah, and they just show an example of mistranslated.
Okay.
For example, in the CG test, there is a sentence like this: the compound is on the board and is translated incorrectly. And for instance-wise, 27.31% of compounds are translated correctly for the CE test. And for each compound, when aggregating all 5 contexts, so 61% of compounds suffer at least one incorrect translation.
I didn't get this sentence. Where these contexts mean?
So if you remember, for each compound, you construct 5 sentences. That's
okay.
That's a 5 contexts, and 61% of them.
All right. So the overall idea is that this problem is very important, but existing approach does not have a better performance, right?
Yeah, they are saying that. And the error rate of preposition is much higher than the noun and verb compound.
Okay, let's move on.
And in their GitHub page, they have the updated data. They say the data on the paper is not the latest.
Well, so you can see the ACL paper does not need to be a technical paper, right? So they just need to review some problems and we can get there. Okay, let's move on.
Yeah, then the last part, they have heavy analysis on the syntactic. For example, they analysis several factors like compound frequency. So they say compound with higher frequency in the training set are easier to infer. Actually, it also confused me here because previously they said the compounds are not very common in the training data, but here they also have data that's like frequency within 1 and 10. But a large percentage of their compound are 0 shot, meaning they don't appear in the training data.
Okay, let's move on. I think this data is not important. But anyway, if someone is interested in these slides, please raise your question.
So next one, next page.
Okay.
Or if I go to the compound length,
all right.
Yeah, item frequency doesn't really have a strong correlation because they think all corpus are simple.
All right. Okay.
And for item co-occurrence, they have this to measure the point-wise mutual information between 2 words, 2 items, AING, and they have this to measure the co-occurrence. And they say the error rate with positive mean PMI have lower error rate, meaning if 2 words are appear more together within n-gram, they will also be translated better. Yeah.
All right. I have no question on these slides.
Yeah, and they have really heavy linguistic factors. So
yeah, I see. So in order to make it into ACL, so they need to do more analysis, right? Okay, so we can move on. Yeah, I have no question on those slides.
Oh, yeah, then the analysis non-verb prepositions. And that.
Yufan, you're kind of building expertise in NLP. So do you have any questions?
Actually, no. I think it's okay, but no very interesting part. Mostly, I think just raise the interesting part, but no concrete method mentioned. So that said this may be important, but I don't think quite well.
What do you mean quite think quite well?
Because there's no concrete
you can see this is an NCL paper, and Prof. Zhang Yue is one of the strongest NLP researchers in this world. So do you have anything learned from this work?
I think the compounds, but they maybe use many patterns, make great effort to.
But anyway, so yeah, no, you need to digest a little bit. So of course we can criticize the papers in any way we want, but this is we're still trying to. I think we still need to try to absorb some good nature from the paper in terms of writings, in terms of experiment, in terms of analysis, in terms of problem identification. Right. Let's move on.
Yeah, and almost the last part, they are seeing the error rate that goes with the context length. It also girl with sentence comprehension difficulties. So yeah, and they say in real world it will be even more difficult, and that's a conclusion. Their main effort is a data set, and showing null models have the drawbacks in the generalization. And I feel it's very heavy. They have
that. Yeah, so this is basically an AM papers. So this is not one of my strongest expertise branch lines. But anyway, I think we can learn something from it. So the first thing I appreciate is about the proposal of compositional generalization. And this is actually very important for NLP, at least from my point of view. But I think the same idea would be applied on computer vision, right? So when we see some image of cats, or see some images of the tigers, see some images of lions, see some images of the cats. So whether we can have some intuitions or generalizations from the other cat-like animal, like puma, right? So this is still something we can think about generalization. And how do we design approach? You can see, maybe this is a very hard problem. The researcher themselves haven't been able to address it within a short time. Maybe the PhD need to graduate, they need a paper. But the things they have given a prepared data set, and what idea can we think to address this problem? So in terms of transformer, things here, I think the one with best expertise on transformer is Yufan, right? And anyone is familiar with the NLP technique like RSTM, transformer, etc. So since these are problems, if you want to address the problems, what is solution? So anyone will try to volunteer to think in this thread. Maybe Yufan. I think that you are the one with most expertise. So they're saying that current approach transformers have better performance. If you are the one who want to address these questions, if you can address these problems, you definitely have another paper. So if you are the one to address it, what do you think about how to address this one? Hello, Yufan.
I think I needed for more reading and digest the paper. I'm not quite sure now.
All right, so maybe this is open questions. So usually we need some explainer, right? Some just like what Jinglian is working on. So we need to understand why the model cannot address these, and why the model have some wrong predictions, right? So on the ball has been predicted as qiu chang, right? So this is not right, and why the model would have such intuition and predictions. Maybe we need to discuss and have then we will design approach for that. But anyway, so I think this is a good paper. And Jinglian, for your presentation, I guess you need to think about the logical chain. And at least from my point of view, at least from my part, I just feel that I know the overall idea, but your presentations have some contradictory effects, and you cannot address the effects well. So whatever the presentations, you need to make every people convinced, and basically the audience want to be convinced. For example, at least for me, I want me to be convinced very much, but the fact is that I'm not convinced. So at least in your presentations, we'll try to think through these facts and at least make the logically coherent.
We can discuss. Yeah.
Okay, so we can discuss maybe later. So and the next
Yeah.
word have to
maybe I think Yufan, for the open question, another possibility is just as you mentioned, this might be the data augmentation. Why not use it as a data augmentation? But the sense is the generated is about 2000, right? Not that heavy when you can build more. I mean,
yeah,
as a
augmentation.
data augmentation, right?
Yeah, I think augmentation might be the way to go.
Yeah. No, I mean just an open question. I think he mentioned this one, right? Why indeed this is maybe not a very good way, but it's a possibility.
Yeah,
the
so
sense there might be some problem. The compound is not, I mean, are not that enough, right?
Yeah, so here the case is that all the atoms, So compound may be unseen, but atom has been seen in the training data. So which
Yeah.
means that the model have seen the training data before, but it hasn't been able to generalize it well.
Yeah, so you
Mm.
can use this as a fine-tune data set, right? I agree that the atoms the model has seen, but the compounds, I think is a little bit new for the model.
I think the guess is that the red car and the blue ball
Yeah.
are all there, but the red ball has been predicted incorrectly, right? So maybe something it appears and it is translated into somewhere else, and those walls are just there. But of course, I think the augmentations is a very is the initial stage, and it must be able to serve as a baseline. But there must be some maybe model architectures, maybe some samplings. So in this case, I think definitely I agree. I totally agree with that. The data augmentations must be could be using at the starting point.
Yeah, but I feel the paper totally manual analysis, right? They try to generate and also annotation, human annotation. It's quite heavy.
It's not that heavy. They must write some scripts. I think the paper is more of the empirical studies. I think it's more of empirical studies.
It's I mean encourage
new research, right? So
no,
research.
No. I mean they need some expert to. I remember there is a part that Jinglian mentions there. I mean, need some human expert to help annotate or.
Yeah, so this is definitely the construct a new data set. So this part needs manual power.
Okay, I see.
Yeah,
I see.
Yeah, so
no more questions.
Yeah, but anyway, so there's an interesting problem to address, but also from this paper, we can see that there's not necessary for us to propose something to address, right? So, but of course, there's involved a lot of manual work, and there's some insights. Yeah.
So it's also acceptable that we propose a problem, a question.
Yes,
also,
maybe in AI it is possible, but in software engineering
cannot, I think.
Unless you can do something like Xiaxing doing.
Yeah,
right,
I know.
Yeah. So how far are we? Blah blah. And how far are we?
But it's hard to make it accepted in
top tier.
Yeah. Seldom, right? Not that. I mean, I saw many IST papers seldom see IXE or I read one before, but not that many.
Yeah, so usually they will submit maybe 10, 20, and they get it maybe 2 or 3 or 5. Yeah, I think so. I think maybe they have a very, very large group, and everyone submit, and a few results get accepted. But for us, maybe we cannot afford to do so. But anyway, so it's good to learn something from their style, at least from the research purification. Okay, so I need to stop the